everyone. I'm here to discuss ionic and covalent bonding with my good friends Freddy Fazbear and his gang. This is Chica the chicken, and this is her cupcake. Say hi, Chica. Chica will now show you her cupcake. She and her cupcake are part of ionic bonding. Here's why. As shown here, we see that Chica is ionically bonding with her cupcake. Chica, a big metallic animatronic, is cuddling with her cupcake, who is a non-metallic. This can mean that Chica is a metaphor, and so is her cupcake for ionic bonding. Let's see another example of ionic bonding, shall we? Here is Freddy Fazbear and his plushie. Him and his plushie are both ionic bonds in the sense of a metaphor. Freddy is an animatronic bear, while his plushie is a non-metallic bear. To completely understand ionic bonding, you must first know what it means. Ionic bonding is when two elements on the periodic table are fused within each other, but they are completely different. So Freddy here, who is a metallic animatronic, with his plushie, which is a non-metallic object, are fused in within each other to create an ionic bond. While Freddy and his plushie are not elements on the periodic table, this is sort of a metaphor for it, as shown and demonstrated on the screen. Now let's move on to covalent bonding. Uh-oh. It's probably not a good idea to explain covalent bonding in front of these two. However, these two are technically covalent bonds, as they're both metals. Okay, that's enough. Get us out of here, Cambot. Not again. Alright, now that we got that mess out of the way, let's get back on to business. Here we have three plushies. These three plushies are all non-metallic, of course, as to explain covalent bonding. To truly get covalent bonding, you have to know what it is. So, covalent bonding is when the same elements are being put together. So like a metal and a metal, like Bonnie and Foxy back there, are put together in order to become a covalent bond. While the plushies that we have here are also covalent bonds because of their element. When dealing with valence electrons, it's almost like imagining a slice of pizza. Each slice shown here represents one valence electron. Each valence electron can be used to gain, share, or lose. They can be given to any and or all elements. Now I will show you Chica eating one of the valence electrons. Good job, Chica. Now on to the results. Will you take a look at that? Chica ate the slice. Now that she ate the slice, she, and every other element on the periodic table, can gain an electron. These three little monsters have worked up an appetite, so they are now going to eat this pizza just like Chica did. As you can see, the little munchkins stuffed themselves. But as you can also see, the pizza is still on there. So that means they didn't eat all the valence electrons. This is because the metal elements, they require more valence electrons than nonmetals do. And you could sort of think of it as like, since the metal animatronics are so big, they need more pizza in order to sustain themselves. While the non-metal ones, they don't really need that much pizza because of their small size. But how are valence electrons related to each type of bond? Well, let's take a look at ionic bonding. Ionic bonding consists of metals and nonmetals, as shown here. We see that Freddy and the plushie are there. Who do you think would get more of the electrons? The plushie, right? Because the plushie is cute. Now, the actual reasoning behind this is because the nonmetals actually have more valence electrons to start out with. So, since they have more valence electrons to start out with, they're the first ones to get filled, while the metals are the last ones to get filled. And because of this, when it comes to ionic bonding, the nonmetals will get filled up first. And then when it comes to covalent bonding, it's either the metals or the nonmetals, whichever group you're trying to fill. Now we are going to discuss about periodic trends. Periodic trends are they exist in a lot of different variety. There's electronegativity, there's polarity, there's ionization energy. Well, we'll be talking about the few very important ones. First up, let's talk about electronegativity. Electronegativity is a measure of the ability of an atom in a chemical compound to attract electrons from another atom in the compound. So, as shown here, we see the Freddy Fazbear gang working hard for maybe a slice of pizza. Once they've worked hard enough, they can get it. Now, if we go over to the nonmetals, or the plushies, as we like to call them, the plushies, however, don't have to work that hard. All they have to do, pretty much, is just stand there, and they'll get them. They'll get it because they're so cute. Just look at them. Just look at them! Now we will go over electron affinity. Electron affinity is the energy change that occurs when an electron is acquired by a neutral atom. So, basically, when you see this word, it means to get energy. So, Foxy over here is getting energy for his belly, and the Foxy plushie over here is getting energy for his belly. Now, they're a lot more different for metals and nonmetals, as metals seem to get less. But if you've seen how big Foxy's body is, then that would explain why he would get less, because there's more of that to acquire. Now, there's a lot deeper meaning than a metaphor, but that's how an easy way to remember it. Now, with nonmetals, there's just, with the Foxy plushie, it's just, there's not enough body. It's just a small little body. It's just a small, cute little body. Finally, let us talk about cations and anions. Cations are used in positive ions, while anions are used in negative ions. Positive ions are usually in metals. Anions are usually in nonmetals. The reason being is because electrons are negative, so as more and more valence electrons are added, more and more negative it will become. So, if we take a look at Chica here, we can see that Chica is looking very happy. She's very, very happy, so she's very positive. And this plushie, it's negative. Just look at it. Just look at it. Thanks everyone that was watching. I hope you all enjoyed this, and I hope you learned something new. Now, it's time for us and the Fazbear gang to take off. Fazbear away!